Hello, mathematicians. So we are on day 5 on page 9 of our Unit 6 packet on solving equations. And today we're going to actually look at our third and final method, the quadratic formula. So before we do so, let's just take a look at the quadratic equation below and really look into why completing the square and factoring wouldn't be good options for this. So I'm just going to put down factoring. And I'm going to put CTS for completing the square. So if I were to factor this, I would look at this and think, okay, well, trinomial, so I'm probably going to want to do X box. And then I'm going to take the C term, multiply with the A term, and I would have 28 on top. Then I would take the B, which is negative 12, and put it on the bottom. So the goal is for me to look at the factors of 28 and see if I add them with either of those pairs give me negative 12. So if I'm looking at the factors of 28, I could be going into my bestie, right? And if I just look, I'll just look at a few, right? 7. Well, we know it's a negative, so I want to have negative 7, negative 4, negative 1, negative 28. That doesn't look good. Hold on. Oops. Negative 28. Right. Negative 2 times negative 19. Right, so if I look at these pairs, if I were to add them up, none of these pairs are going to give me negative 12. Okay, so in this case, there's really no factors that work. All right, let's look over at completing the square. So here I would essentially end up having to move the the C term to the other side. So I would end up at 7p squared minus 12p equals negative 4. And then I would get rid of the A term, so then I would start dividing. And I would end up at p squared minus 12 over 7p equals negative 4 over 7. And then I look at this, I'm realizing that I'm going to have to deal with some really nasty fraction. So here I would say dividing out 7 created, I'm going to put them as nasty fractions. Okay? So it's not really ideal to be using either of these two methods. Well, if all else fails, we will go to our handy dandy reliable quadratic formula. So let's just scroll down a bit and take a look at this section now. So for substituting the quadratic, you want to make sure that the equation is equal to 0. And you want to put the equation in standard form. So that's a times x squared plus bx plus c. Okay? And you want to be able to identify the a, the b, and the c numbers, and then you want to plug it into the formula. Oh, I wish I had Michelle. This is when you truly miss your co-teacher. Michelle does all the singing for me, so I'm going to try my best. So to remember the formula, you could sing or hum the phrase below to the Pop Goes the Weasel song. So x equals negative b plus or minus the square root of b minus 4ac all over 2a. Shout out to Michelle, you're super missed right now. So if you write this down, we would have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I was you, I would definitely be making a note that this formula does not have to be memorized. That is given to you on the Math Regions reference table, right? So maybe you just want to make a note and write on the Regions reference sheet. Okay? And we're going to go ahead and try a problem. So we're now on page 10. We're going to just look at number 1. So the first thing is asking is making sure that the equation is equal to 0 and in standard form. Well, here we know we're going to have to bring the negative 9x to the other side. So inverse operation, I'm going to plus 9x on both sides. And I definitely want to make sure that it's in standard form. So I'm going to have 2x squared plus 9x minus 18 equals 0. And then I want to actually pull out a, b, and c. So here a equals 2, b equals 9, c equals negative 18. Okay, with this formula, I will say staying neat and organized is number 1. Okay, think about Maria when you're doing your work. So here I would then plug this into my formula. So I have x equal negative b. Another hint is, I remember telling you girls in the beginning of the school year how important parentheses are, and there will be a time where we definitely need to make sure that our parentheses are accurate and that we're using them wisely. Well, this moment has come, ladies. So parentheses everywhere. So for b, we'll have 9 plus or minus the square root, again parentheses, of b squared, so 9 squared minus 4 parenthesis times 2 parenthesis times negative 18, okay? And make sure that your square root covers all of that, okay? And then this whole thing, okay, is divided by 2 times a. Okay? Then we're going to do some simplifying. So let's pull out our bestie. And we always want to simplify first what is inside the radical. Okay? Actually, let me undo that. You want to write what's inside the radical, not the actual radical itself, just what is inside. So in your calculators, all right, we're going to a new screen. We're going to put parenthesis 9, close parenthesis, squared, minus 4, parenthesis 2, close parenthesis, parenthesis, negative 18, close parenthesis. Okay? Then we're just going to plug that right back in. So we'll have x equals negative 9 plus or minus the square root. And what we put underneath there was 225. Okay? And 2 times 2 is 4. Now we get to this point. Now you want to simplify your radical. Do I have any more room here? Can I scroll up? All right, I'm going to scroll up a little bit. So now we will have x equals negative 9 plus or minus 15. And all of that is being divided by 4. Okay, if you noticed how I'm lining up my work, very important. Okay, then from here, we want to simplify this. So you could break this up and we could have x equals negative 9 plus 15 divided by 4, and x equals negative 9 minus 15 divided by 4. We'll put each of them in our calculators. So here we'll have x equals 3 over 2. And here we would have x is equal to negative 6. All right, thanks, ladies.